Hi physics students, we're going to do a short review here on the basics of waves. We're going to look at the characteristics of waves, uh, what are transverse waves, longitudinal waves, and how do we measure waves, specifically how do we find the velocity of waves. The basic definition of a wave is it's just simply a disturbance. It's a rhythmic disturbance that carries energy. And so what moves in a wave is the energy. But for a wave to move, it has to have a medium. That's some kind of a substance. And so it's a material through which the wave transfers the energy. It could be a solid, a liquid, a gas, or a combination of any of these. The one exception are electromagnetic waves that don't need a medium because they travel through space. There are two types of waves you need to be familiar with. One is longitudinal and the other is transverse. Note that both of these types of waves, the energy transport is in the same direction. They just move differently. In a transverse wave, the medium moves perpendicular to the direction of the wave. So in this example, the wave is still moving in this direction, but the medium is moving up and down. You also need to be familiar with wave anatomy, and you need to be able to label the parts of a wave. And so in this example, we're going to first look at amplitude, which is simply the height of the wave from the center line to what we're going to call the crest of the wave. The distance from one crest to another crest is what we refer to as the wavelength. And there's simply another example here of wavelength. You can do the top of the wave or the bottom of the wave. And the bottom of the wave is called the trough. The amplitude is also correspondent to the actual amount of energy the wave has. And so the higher the amplitude, if the amplitude went further down or further up, we would know that the wave has more energy. Now it's your turn to label the parts of the wave's anatomy. And so in a moment the video is going to stop and you're going to be prompted to answer what parts A, B, C, and D are. The other type of wave that we mentioned are longitudinal waves. They're also known as compressional waves because they compress a lot like a slinky. And so the energy is moving left to right, and the motion of the wave, a medium, is also moving left to right. In longitudinal waves, you can see how it's identified. The wavelength is the length of both the compression and the rarefaction of the wave. I know those are weird terms, but just think of a slinky. At the point where the slinky compresses, that's like the release or launch of the energy, and so that's correspondent to the amplitude or force of the wave. As we measure waves, we also have to consider frequency, and this is kind of a simple one to remember because a wave that has a higher frequency simply has more frequent waves. It's the number of waves passing through a point in 1 second. And so if you look at the top example and you see you've got one wave two waves. There's two waves that pass by from this point to this point in 1 second. And you look at the bottom wave and you have more waves. 1, 2, 3 full waves that pass by. And so the bottom example has a higher frequency. But notice also that the distance from crest to crest, which is the wavelength, is shorter in a higher frequency wave. You will also need to be able to determine the velocity of the wave. Remember, velocity, it's just another term that describes speed. And so you're already familiar with this. The velocity of the wave is just simply the speed of the wave as it moves forward. And the speed of the wave is also determined by the medium. Remember, the medium is what the wave is traveling through. It could be air, it could be the ground, it could be water. And so to find velocity, we need to know the wavelength, which is this funky looking letter. It's actually a lambda. And you need to be able to know the frequency. Remember, the wavelength is the distance measured between crest to crest or trough to trough. The frequency is how many full waves pass by a given point in 1 second. You can see that velocity is measured in meters per second. Wavelength is measured in meters because it's distance. And frequency, and this is a new term for us as well, is measured in the units hertz. So now I'm going to walk you through a couple examples of how to do problems, physics problems with waves. And so the first one is this. I'm asking you to find the velocity of a wave in a wave pool if its wavelength is 3.2 meters and its frequency is 0.60 hertz. Notice that, and this is really important, that you write down the details of what you know. And so on the left you see the given. First of all, what we're looking for velocity. That's why there's a question mark. And the wavelength is what we know, so we write it down there. And we write also what we know, which is the frequency, right down there. And so here's the triangle of physics. We have velocity on top and the wavelength and the frequency on the bottom. And so what we're looking for is velocity. So we're going to cover that one up. And we know that we need to take wavelength, because these are both on the bottom. It's going to be wavelength times frequency. And you can see that written out under the work. And so what do we do then? We take velocity equals wavelength, 3.2 meters. Notice I included the units, times 0.60 hertz. And so the answer is going to be 1.92 meters per second. Note it's the same set of units that we've used before when we find velocity or speed. Now it's your turn to do this problem. The problem is this: an earthquake produces a wave that has a wavelength of 417 meters and it travels at 5,000 meters per second. So what is its frequency? I'm going to go ahead and pause the video and then let you work this out on a sheet of paper. So let's go ahead and finish this problem. Again, make sure you write down what you know. So we know that the wavelength is 417 meters. So we write it down there. We also know its velocity it travels at 5,000 meters per second. Here's what we're looking for. We're looking for the frequency. So what do? We cover up frequency on our triangle of physics, and we know that we're going to take velocity divided by the wavelength. We know that the velocity is 5,000 meters per second. Again, I'm carrying down the dividing sign, so we know what I'm doing. We divide it by the wavelength, which is 417 meters. Remember, wavelength is the distance from the crest to the crest of the wave. So what did you get? The answer for the frequency in this problem is 12 hertz.